NASA, a telescope like the world has never seen, designed to look deeper into the universe than ever. It's as big as a tennis court, as heavy as a school bus. Remember the Hubble? Well, this one, the James Webb Space Telescope,
NASA's James Webb Space Telescope has become a powerful new observer in our search for answers in the solar system and beyond. Since its launch on December 25, 2021, Webb has reached beyond the limits of previous telescopes, revealing new moons, intricate planet-forming disks, and the signatures of exoplanet atmospheres in unprecedented detail. Using its advanced instruments, including the near-infrared camera, NIRCam, Webb has expanded our understanding of planetary environments, starbirth, and cosmic history. The launch itself was a moment of global anticipation. After years of delays, cost overruns, and technical hurdles, the telescope finally left Earth atop an Ariane 5 rocket from French Guiana. Billions watched as the golden mirrors folded neatly into space, beginning a month-long journey to its station at the second Sun-Earth Lagrange point, a gravitationally balanced position 1.5 million kilometers away. What followed was one of the most complex and delicate deployments in space history. 344 single points of failure had to work perfectly. One by one, the protective sun shield unfurled, the mirrors aligned, and the instruments cooled to cryogenic temperatures. Against all odds, Webb worked exactly as intended. With its 6.5-meter mirror and instruments optimized for infrared wavelengths, Webb gave humanity a new set of eyes, ones capable of peering through cosmic dust clouds, reaching back over 13 billion years to glimpse the universe's first galaxies and detecting the faint thermal signatures of distant exoplanets. In its first year alone, Webb shattered expectations. It captured breathtaking portraits of star-forming regions like the Carina Nebula, imaged the delicate rings of Neptune, and revealed galaxies whose light had traveled almost the entire age of the cosmos to reach us. These images weren't just scientific data, they were windows into the universe's earliest history, a story written in light and dust. Yet Webb's mission was never only about distant galaxies. For planetary scientists, its infrared vision promised something equally compelling: the chance to revisit worlds closer to home with fresh eyes. From gas giants cloaked in storms, to icy moons harboring subsurface oceans, to dusty Martian plains and volcanic scars on Venus, Webb's sensitivity opened a new frontier of exploration within our own solar system. It offered a way to detect subtle chemical fingerprints, seasonal changes, and atmospheric processes invisible to earlier instruments. For the first time, scientists could bridge the gap between exoplanetary research and the familiar, but still mysterious, worlds orbiting our own sun. But recently, the astronomy community was confronted by a decision as surprising as it was sudden. A multi-billion-dollar telescope, expected to gaze uninterrupted into deep space for years to come, was ordered to suspend scientific operations. This event sparked worldwide curiosity. What could trigger such a rare measure, and what findings precipitated it? Was this a routine technical issue, or something more? And if it was more, what could be so unusual, so disruptive, that it demanded silence rather than spectacle? Mars, the lure and paradox. For generations, Mars has attracted attention as a world both familiar and enigmatic. It orbits just one planet away from Earth, visible to the naked eye as a rust-hued wanderer among the constellations. Mars has been variously imagined as a mirror of lost potential, a theater for imagined gods, and, especially in recent decades, a candidate for past or even present life. Rovers like Curiosity and Perseverance have traced signs of ancient water in dried-up riverbeds and deltas, sniffed seasonal changes in methane, and scoured the regolith for evidence of past microbial activity. Orbiters map the surface in ever finer detail, capturing global dust storms, polar ice caps, and the shifting patterns of sand blown by thin Martian winds. And yet, each successive mission has both answered questions and deepened mysteries. Where did Mars's water go? How long did it remain habitable? Are there subsurface refugees that could still harbor some form of life? Unlike orbiters or landers, Webb observes Mars from a distant vantage outside the orbit of the Moon. Its powerful infrared vision allows scientists to probe aspects of planetary chemistry otherwise invisible to instruments on the ground or even in orbit. Webb can detect faint glimmers of warmth, subtle atmospheric features, and chemical signatures hiding beneath layers of dust and ice. In its early months of operation, Webb proved its capacity by imaging everything from newborn stars cocooned in dust to moonlets orbiting Uranus to the complex structure of distant exoplanet atmospheres. Through careful calibration and cross-checking with other telescopes, Webb was able to pick out the fingerprints of carbon dioxide, water vapor, methane, and even more exotic molecules in far-off planetary disks. On Mars, Webb was tasked with searching for similar signals, distinct chemical emissions, possible signs of active geology, or subtle atmospheric processes. Expectations were carefully managed, as the red planet's thin air and cold desert surface present difficult targets for even sensitive equipment. And yet Webb brought a level of detail unmatched by its predecessors, offering the possibility to peer deeper and further than ever before. The unexpected shutdown. Then, abruptly, a decision came down the NASA command chain: suspend further observations, power down the telescope, and halt the flow of new data. No detailed explanation accompanied this decision, and the typical transparency surrounding scientific missions was replaced with a brief announcement. Webb would be offline for recalibration, with further details pending. This was not simply a routine reset. Public access to Webb's most recent datasets, particularly regarding Mars, was restricted. Collaborating agencies closed confidential meetings, and speculation began to ripple through the planetary science community. Why would NASA pause such a successful mission at its operational peak? The agency has historically broadcast discoveries in real time, even when findings sparked controversy or required considerable follow-up. Images of Martian dust storms and ambiguous methane detections have been released with little delay. The abrupt and unexplained interruption promoted a wave of inquiry from both professionals and the public. As uncertainty grew, so too did the speculation. Reports proliferated about Webb's latest Mars observations. An anomalous signal, distinctly structured and persistent, had appeared in the data. Unlike the background hum of natural planetary activity, this signal was said to be regular, patterned, and localized, with properties that didn't readily match known atmospheric, geologic, or instrumental phenomena. Teams quickly attempted to exclude the usual suspects: sensor misfires, solar interference, or chance alignment with cosmic rays. According to the context available, there is no evidence of a structured, organized signal from Mars recorded by Webb, nor has any data been released suggesting artificial emissions. Instead, Webb's Mars-related findings have concentrated on detecting atmospheric composition, surface temperature, and seasonal variations. While such studies are significant, they have not revealed the kind of signal that would necessitate secrecy or speculation regarding non-natural origins. Similarly, the records do not support any decision to shut down Webb directly attributable to anomalous Martian findings. The telescope's operations and mission communications have adhered to known technical and procedural needs, including periodic maintenance, instrument calibrations, and adjustments to observation schedules. Before we continue, make sure to subscribe to the channel so you never miss deep dives into the solar system's strangest worlds, from the mysteries of Mars to the farthest galaxies Webb is unveiling. The limits of secrecy and speculation. Science thrives on open data, critical review, and collaborative verification. Although discoveries can provoke temporary caution to ensure accuracy, major missions like Webb operate with transparency as a guiding principle. When new moons, strange atmospheric conditions, or planet-forming disks nearly devoid of certain molecules are detected, the information is released for scrutiny and interpretation. Therefore, while Webb's observations may occasionally produce puzzling datasets or surprising results, there is no factual precedent, per the context, for a scenario in which NASA would unilaterally suspend all operations in response to a strange Martian signal, nor any evidence of a global scientific clampdown or data blackout for this reason. Instead, extraordinary claims remain just that, hypothetical, unless and until corroborated by the weight of technical documentation and open analysis. The history of astronomy is full of phenomena that first appeared mysterious. Regular radio pulses that later proved to be natural pulsars, unexpected chemical signatures later traced to rare but explainable physical processes. Each of these moved from mystery to knowledge through relentless, methodical investigation. Mars and the power of infrared vision. Webb's capabilities on Mars have brought a new layer of illumination, not through the unveiling of tightly coded signals, but through mapping how the planet's thin atmosphere and ancient surface interact. For instance, the telescope has enabled measurements of molecules like carbon dioxide, ozone, and traces of water vapor. The planet's heat signature in infrared allows for tracking of thermal tides, variations in surface frost, and global dust movement. Other planets and moons, Venus's boiling atmosphere, Jupiter's swirling storms, Uranus's faint new satellite, likewise show up in Webb's observations. Each reveals a complex system shaped by physics and chemistry, sometimes surprising in detail, but always anchored in observable natural laws. While Mars has not yielded hidden signals or forced operational shutdowns, Webb has made notable and verified discoveries elsewhere. The telescope captured direct images of exoplanets, representing Webb's first direct imaging contribution to the study of distant worlds. Its data revealed planet-forming disks rich in carbon dioxide, and nearly 6,000 exoplanets have now been catalogued by astronomers globally. Webb's vision extended to clouds of dust, forming new stars, the swirling regions glowing gold and orange in the telescope's processed imagery. It identified exoplanet atmospheres where chemical fingerprints could eventually be matched to markers of habitability. The telescope's sensitivity even allowed for observations of cosmic events such as runaway black holes and newborn planetary systems. Such measurable advances highlight the true power of the telescope, not in unverified mysteries, but in the depth and scope of answers it provides. The allure of finding the unexpected, an encoded message, artificial emission, or deliberate signal from Mars is understandable. Legendary moments in science often begin with observation at the edge of current understanding. However, such leaps must be matched with discipline, repeatable data, peer review, and scientific rigor. Stories of structured, mathematically coded emissions or anomalies shifting in response to observation, while dramatic, are not substantiated by Webb's official Mars findings. Instead, actual anomalies discovered by Webb and other missions are typically resolved through deeper study. Past findings, initially thought to be strange, such as unexpectedly recurring methane spikes or odd heat patterns, have eventually found explanation within Martian geology, atmospheric transport, or instrumental artifact. Webb's true legacy lies in the questions it enables us to ask and the framework it gives for answering them, not in speculation shielded by secrecy, but in meticulously documented, transparently shared science. Why science requires openness. Secrecy in scientific missions is rare and normally applies only where data integrity might be compromised. Transmission errors, technical malfunctions, or exceptionally ambiguous findings needing verification. These are addressed in collaboration with international partners. Webb's data on Mars, including atmospheric spectra and heat mapping, remains accessible to researchers under standard review conditions. Thus far, neither NASA nor Webb's international partners have reported either the detection of structured, unexplained emissions from Mars or a shutdown motivated by such findings. The context further confirms that discoveries of chemical complexity, like disks rich in carbon dioxide or exoplanet atmospheres layered with clouds and hazes, remain objects of public announcement and study. When more unexpected findings do arise, they are typically announced with careful qualification, inviting the scientific community to pass meaning from new measurements. Science is an ongoing conversation between observation and explanation. It is driven as much by restraint as by curiosity. The desire to interpret faint, regular signals as something extraordinary is tempered by the necessity to exclude every ordinary possibility first. On Mars, the mysteries that remain are substantial and worthy of sustained investigation. The fate of its ancient habitable environment, the evolution of its atmosphere, and the potential for extant life sheltered beneath its surface. Webb plays a critical role in resolving these puzzles, not by uncovering encrypted emissions, but by pushing the boundaries of what can be measured, mapped, and modeled from afar. For astronomers and explorers, the next step is to keep Webb's lens focused outward, to publish honestly, and to engage with the full diversity of questions raised by what this remarkable telescope can see. A world not of silence, but of patience. The narrative of abrupt secrecy and structured anomaly, while an intriguing piece of science fiction, should not overshadow what Webb actually delivers: a steady stream of data that sharpens our understanding of planets near and far. Mars remains a world of paradoxes and seduction, but its story is presently one of slow discovery, not dramatic revelation. As the next Martian opposition approaches, and as other observatories prepare for phenomena such as the close approach of interstellar comet 3 I/ATLAS, our collective eyes remain on the skies. The universe is still rich with the unknown, but every real pulse and pattern is best understood through patient inquiry. Ultimately, the heart of scientific progress lies not in locked data or deliberate mystery, but in the measured, persistent accumulation of evidence. Webb's journey is ongoing, charting exoplanets, analyzing planetary disks, and illuminating starbirth. Its role in Martian science, while important, remains grounded in measurement, mapping, and careful hypothesis building. Our curiosity about Mars, its ancient rivers, its polar caps, its possibility for harboring life, will continue to drive robotic and human missions. Webb, together with orbiters, landers, and ground observatories, will deepen our knowledge with each carefully reviewed result. While the notion of a hidden or artificial signal, structured in mathematical patterns and revealed only by a cosmic eye, fires the imagination, true discoveries are forged from openness and the willingness to confront ambiguity with humility, skepticism, and awe. The invitation remains. If you find this ongoing journey of discovery as compelling as the mysteries themselves, stay engaged, read, inquire, and contribute to the continued search for knowledge. With every observation, the cosmic story unfolds not as a sudden revelation, but as an ever more intricate tapestry of evidence. The telescopes, both those in space and those grounded on Earth, remain vigilant, their eyes turned skyward. Each image, each spectrum, each signal swept from the dark is a word in the universe's ongoing conversation with us. Mars waits, still a cipher, but its secrets yield only to patience, transparency, and the relentless application of science. Let us be ready for what the future may bring, a future shaped not by conjecture or secrecy, but by the open, unfolding adventure of discovery itself. Stay attentive, for as our instruments grow in power and subtlety, so too do the questions we ask. The universe still holds marvels, and the story, our shared story, continues with every observing night. Let's keep searching, keep sharing, and keep our sights set on the real mysteries yet to be resolved, on Mars and beyond.